Yes. Hello students. In this video we will learn about noise models in image processing. Right? During image acquisition or transmission, image often get affected by unwanted disturbance. That is called noise, right? So this noise reduces image quality and it makes some image analysis more difficult, right? So by understanding these noise models, it helps us to analyze the characteristics of noise and apply appropriate techniques to remove this remove these all things, right? So the first session, first we can learn about what is noise in digital images. Actually, noise refers to random variations in pixel intensities. So the pixel intensity value that do not represent the true information of the image, right? That's really that only we are calling as the noise, the variations, right? It will be distorted pixels or grainy patterns, something like unwanted spots. It will be adding with that, right? So this noise can occur due to several reasons. So such few reasons we can discuss on now. So first thing is by the sensor noise from the digital cameras, camera sensors. Uh, the sensors also have some noise like some making some like unwanted spots, right? Then poor lighting conditions like temperature or lighting systems maybe damage or images quality, right? So while we capture the image, during while we capture the image, this kind of problems may occur. Transmission errors is while sending image through the communication channels during that time, this may happen, right? Electronic interferences in imaging during the electronic signals. And the next one is data compression errors. While compress the data, some kinds of errors may produce. So these all of the noise can affect by object detection and um, image segmentation and pattern recognition. So the next one is noise models. What are the noise are there? What are the kinds of noise? So noise can be divided into various types. Like the researchers or engineers like understanding the statistical behaviors of the noise. So based on the model, suitable filters we can apply and restore, some restoring techniques may be applied to reduce the noise and while preserving the important original image. So noise in images can generally divide into two types. One is additive noise, another one is multicative noise. The additive noise in the sense noise is added with original image, right? Multiplicative noise in the sense noise will multiply with the image, right? So the various types of noise models are there. So the various models are the first thing we can say is the Gaussian model. Gaussian noise. The Gaussian noise is the most common noise. Here we will be using some normal distributions mean and variance, right? Mean value, we find the mean value and variance. This type of noise usually occurs when due to as thermal noise in electronic circuits and camera sensors, right? So this Gaussian noise slightly changes the pixel intensity values across the image. If the intensity value changes, total image marginality will be changing, like blurred or grainy. It will be displayed. So the second noise is salt and pepper noise. That will be calling as impulse noise. Right? Impulse noise. So this noise appears as a random black and white spots. The pixels will be scattered across the images as black and white. Okay? So the black pixels represent salt noise. Salt. Then the white pixel represents salt and black pixel as pepper noise. Okay? Like what we are calling as the salt and pepper noise. White and black noise. So it is usually caused by faulty sensor elements, transmission errors, while converting the analog to digital, digital to analog conversion during while converting the data will be happening, right? So this will be often removed by using this median filter. Median filter will be very helpful to remove it. The next one is Poisson noise. Poisson noises are related to statistical nature of the photon detections in an imaging sensors, right? This commonly occurs low light imaging environments. Actually. The noise depends on the intensity of incoming lights, so it varies across the images. So this will be found in medical imaging, astronomy, and this like scientific imaging systems commonly appearing. Right? Then the fourth one is spectral noise. So the spectral noise comes under this category of multiplicative noise. It will appears in granular patterns like images, right? So from where it is captured, the image is captured using radar systems or so solar imaging or ultrasound medical imaging. So the areas it is happening. So it will be reducing the image contrast and makes objects detection by the spectral noise will be making find the object detections like difficult. So we have to remove it. So periodic noise appears in repeating patterns like stripes. It will be displaying as stripes and images. Right? So it is often caused by like electrical interferences, the hardware problems during the image acquisition. While we capture the image through the device, the hardware have something problem occur. So because of that, this kind of errors strikes. So these noise can sometimes be removed using the frequency domain filtering techniques. Okay. Frequency domain is useful to remove this kind of noise. Then noise reduction techniques. However, we can reduce these noise. So to reduce noise, we have to improve the image quality and several filter techniques can be used. Right? That's why we have discussed already that mean filter, median filter, Gaussian filter, adaptive filter, etc. So the mean filter is basically the purpose of mean filter to replace each pixel values with an average value of its neighboring pixels. Will be helping to smoothing our images, making the smooth like low filters. The next filter is median filter. Median filter replace each pixel with the median value of neighboring pixels. The first mean filter is replacing the average value of its neighbors, and median filter is replaced by median value of neighbors. Right? So here median filter will be useful to remove the salt and pepper noise. Gaussian filter. The Gaussian filter is used to weighted average to reduce Gaussian noise. The Gaussian filter is useful to reduce the Gaussian noise. Right? An adaptive filter. Adaptive filter, we can see this filter adjust based on the local image qualities. Based on the property, it will be adjusting. Okay. So these are the types of noise which we use, filters which we use to reduce the noise. So finally, I summarize. So by this noise models describe the statistical characteristics of unwanted disturbance in digital images, and common noise types includes what are the noise, Gaussian noise, salt and pepper, and Poisson, speckle, and periodic noise. By understanding these noise models, we can apply suitable filtering techniques to improve image quality and accuracy in image analysis. Okay, thank you for watching this video.